ever really thought about what happens in that tiny sliver of time between you clicking a link and a web page just appearing? Well, it's not magic. It's something called the TCP/IP model. Today, we're going to break down that entire process from your click all the way to a global connection.
So imagine this. You're scrolling through LinkedIn, you see an article that catches your eye, you click it, and poof, there it is. But what is actually going on behind the curtain in those few milliseconds? Well, that whole seemingly instant process is the TCP/IP model doing its thing. You can think of it as the official rulebook for the internet. It's the foundation that dictates how all data gets sent and received across the entire world. So here's what we're going to do. We're going to break down its 4 layers using a really simple postal service analogy. We'll also look at the real-world security risks that pop up at every single step, and I'll even give you a practical troubleshooting tip that you can actually use. All right, let's dive. Okay, our journey starts right at the top with layer 4, the application layer. This is the part of the internet you actually see and interact with every day. It's your browser, your apps. It's where your request to see that LinkedIn article is born. I want you to think of this layer as the front desk of our digital postal service. When you open your web browser to go to LinkedIn, you are literally talking to the application layer. It takes your request, hey, show me this page, and gets it all prepped, kind of like how you'd write a letter before you put it in an envelope. And this layer uses different languages or protocols for different jobs. HTTP and HTTPS, that's the language of web browsing. DNS, that's like the internet's giant contact list, turning a name like LinkedIn.com into a phone number your computer can actually call. And things like SMTP and FTP, those are just the languages for sending emails and files. Now, let's talk security. What if that digital letter you're sending or receiving contains a virus? That's a huge problem. This is where things like phishing and malicious web traffic happen. To stop them, we use something called a web application firewall, or a WAF. It's basically a security guard for the website, checking every single visitor before they're allowed inside. All right, next up we have layer 3, the transport layer. So, your letter is written, but you can't just send a bunch of loose pages through the mail, right? It's time to package it up and get it ready for shipping. The transport layer is basically the logistics department. It takes all that data from the application layer, chops it up into smaller, more manageable pieces called segments, and then decides the best way to ship them. It's all about making sure that data gets from your device to the server and back again reliably. And right here, we get 2 main delivery options, TCP and UDP. TCP is like certified mail. It's super reliable, it checks to make sure every single piece arrived, and it puts them all back in the right order. This is what you absolutely need for a web page to load correctly. Now, UDP is more like a postcard. It's way faster, but, a postcard might get lost in the mail. This is perfect for something like a Zoom call, where a single dropped pixel is way better than a long frozen delay. So, while your digital package is in transit, someone could try to snatch it. This is where a threat called session hijacking comes in. Our main defense against this is Transport Layer Security, or TLS. You've seen this. It's the S in HTTPS. It creates a totally encrypted tunnel, making your data completely unreadable to anyone trying to eavesdrop. Okay, moving on down to layer 2, the internet layer. Our data's all packaged up. Now we need to put the full address on the envelope and figure out the exact route it's going to take to get there. This layer is like the global postal sorting center. It takes those segments from the transport layer, puts them into packets, and then stamps each one with a source and a destination IP address. Then its main job is to route these packets across the huge, complex networks of the internet to find the best and most efficient path. The star player here is IP, the Internet Protocol, which gives every single device on the network its unique address. You've also got ICMP, which is kind of like the network's error reporting system, and ARP, which helps connect that digital IP address to the physical hardware for that very last step of the delivery. Security here is all about protecting the route. An attacker might try to fake an IP address, that's called IP spoofing, or they might try to clog up the network highways. Firewalls act like the traffic cops for this layer, blocking any unauthorized traffic. And VPNs? They create a private, encrypted tunnel for the entire route, hiding your packets from anyone who might be watching. And finally, we've made it to the foundation, layer 1, the network access layer. This is where the digital world physically meets the real world. The route is planned, the package is addressed, now it's time to actually get it moving. This layer is the actual physical stuff, the mail trucks, the roads, the delivery routes themselves.
It takes the digital packets from the internet layer and converts them into physical signals. We're talking electrical pulses for an Ethernet cable or radio waves for Wi-Fi, so they can be sent across real physical network hardware.
Yep, this layer is all about the hardware. Ethernet cables, Wi-Fi signals, and every device has a permanent, unique hardware ID called a MAC address. So if an IP address is like your home address, the MAC address is like your specific name on the mailbox. It's that final, super specific destination.
The biggest risk down here is pretty simple. Someone trying to plug into your network when they're not supposed to. We use something called Network Access Control, or NAC, which acts like a bouncer, checking every device's ID before it's allowed in. We can also set up virtual LANs or VLANs to build separate private networks on the same physical hardware, kind of like having different secure departments all in the same office building. And there you have it. That is the entire journey from the top all the way down to the bottom. Let's do a super quick recap just to put all these pieces together. So let's run through it one more time. The application layer creates your request. The transport layer packages it up. The internet layer slaps an address on it and finds the best route. And finally, the network access layer sends it all flying over your Wi-Fi or through a cable. 4 simple steps that make the entire internet work. And here's that pro tip I promised you. If a website isn't loading, try troubleshooting in reverse, from the bottom up. First, check your physical connection. Is your Wi-Fi on? Is the cable plugged in? Then see if you can reach the server's IP address. After that, check if a firewall is blocking the connection. And finally, is the website's name actually working? Seriously, this step-by-step process can solve most connection problems you'll run into.
Okay, quiz time. First question. Which layer is responsible for assigning IP addresses? I'll give you a second. If you said the internet layer, you are absolutely right.
Question 2. For a high-speed Zoom call, are you more likely to use reliable TCP or fast UDP? Think about it. Yep, you'd use UDP, the postcard, because for video, speed is more important than perfect reliability. And last one, what's the security control that protects your browser from bad websites, right at the application layer? The answer is the Web Application Firewall, or WAF. Awesome job. Hey, if you found this explainer helpful, do me a favor and hit that subscribe button. And I really do want to know, what's another tech topic that just seems way too confusing? Drop it in the comments below and it might just be our next explainer. Thanks so much for watching.
Thanks for watching. Like, share, and subscribe.